Afternoon, Mr. Sean.
Hey Maurice, how you doing?
All right, sir.
You got a chance to look through the recordings and the notes?
Not the recording. The notes though. The notes. I went through the whole thing and do some practice.
How you feel?
Well,
Going back?
there are a few things I need. I'll get most of them, but there's a few things I need to ask you about.
All right. Well, you are here alone, so why not use the
Yeah,
opportunity?
yeah. And, and sure. Well, I don't have the thing up now. The notes that you sent me.
Mm-hmm.
But I did write off something, and I know for example 7. Give me a few, Mr. Sean.
So again, Papa?
I was saying, give me a few.
Okay.
Oh, you have it. Oh, you have it. 1 minute. Oh, yeah, Mr. Sean.
Mm-hmm.
Yeah, man. So that one I wasn't understanding from the
You said example 7. This one in particular?
example 7.
Mm-hmm.
Yeah, man. From the first part of the solution where you have data of x and you say 0, 1, 2, and then f of x equals to 5 is in the last from that point.
Mm-hmm.
Not sure what happened there. So.
All right. So the question says to find a root of an equation x cubed minus x minus 1. So it's asking us to find a root, meaning that we need to find one solution of many solutions. You say to me, how do I know that there are many solutions? Because the order of the polynomial tells me how many solutions it has. So I should be able to find 3 solutions because it's x cubed. I should be able to find 3 solutions. Now the question says to find a root, suggesting just one root it wants me to find. But it says to me that I'm supposed to be using the Newton-Raphson method. Now, it did not give me anything more than just the equation. Now, in order for me to find a root of that, I need to investigate what happens to the equation as it moves from positive through 0 to negative. What do I mean? When I substitute 0 into the function, because I'm looking at the function, when I substitute 0 in there, I'm going to get 0 cubed, which is 0, minus 0, which is still 0, and 0 minus 1 is negative 1. That's why I arrive at a negative 1 here for f of x. Then I'm going to substitute 1. So I'm going in sequence.
Wait, hold on. That last part again. You can repeat that last part.
Sure. So I'm selecting random values, random and arbitrary values, to substitute into my function. Because what I'm trying to do is to see, is to do an investigation. I'll tell you what the investigation will yield. So when I substitute 0 rather, into the function, anywhere in f of x I see x, I'm going to put 0. So I'm finding f of 0 now. So it's going to be 0 cubed minus 0 minus 1.
Right. So that way just give you minus 1. Hello?
And when the function I see x, I'm going to put 1. Looking at my function.
Hold on, Mr. Shan. Cut out. The last thing I heard was one where you said you're using 0. Yeah, it's like it cut out a while ago.
All right, no problem. So now that I've found my f of 0, I now need to move on to f of 1. So anywhere in the function I see x, I'm going to substitute 1. So I'm putting 1 right here. So f of 1. 1 cubed is 1. 1 minus 1 is 0. And 0 minus 1 is minus 1. So this is negative 1 again. I still don't get what I want. And you may ask me, sir, what it is that you want? And I'll soon tell you. Then I'm going to move on to the next number. You notice I'm moving in sequence. Start with 0, negative 1, and then, 1, and then I go to 2. There are other examples where I may have to start with a negative value, and I'll show you how to identify those as we do more questions and past paper questions.
All right.
So we're moving to 2 now. So anywhere in the function I see x, I'm going to put 2. So f of 2 is going to be 2 cubes, which is 8. 8 minus 2 is 6. 6 minus 1 is 5.
Right.
And then I feel good because I'm getting what it is that I want. Sir, you keep saying that.
Yeah, which is
what is it that you want? All right, look here. You notice I have a negative value here for my f of x and a negative value here for my f of x. That will tell me nothing. But you see it have a positive value here now. It means in order for me to move from this negative, I'll have to pass through 0 first to get to this positive talk truth.
Yeah, man.
So passing through 0 would suggest that I cross over one of my solutions, one of my roots.
Okay.
Right. So when you talk about roots, is one of the solutions it's talking about. So somehow I would have crossed over one of the roots of the solution for this stuff. Now, if I cross over between 1 and 2, I cross over the roots. It means that my answer is supposed to lie between 1 and 2. Talk truth.
Hold on, sorry. Repeat that part. You say if you cross over what?
If I see that I cross over because I move from negative 1 to positive 5, so the mere fact I move from negative to positive, it means that I'd have crossed over 0. Don't.
You're right. Good.
So 0 is going to be my exact root. 0 is going to be my exact root. Let me just point it back to you. After my iterations here, see my exact root right here, so? My exact root is where it's equals to 0, where f of x equals 0. Where my value is equals to 0 here, because I'm crossing over this axis. So this is where the exact root is. So very good. So my exact root is here. So what happens is that I'm positive up to this point. Then I cross over the root and I go negative. So at this point, x equals whatever value. I know y equals 0 right here, so but x is equals to some value. The mere fact that I cross over from being positive down to this side to be negative, it means that I would have passed my exact root right here. So you see that?
Okay, yes sir.
Good. So now that I've seen that I've passed my exact root because I moved from positive to negative, I now need to find what that root is. How do I know that I cross over now? Because I moved from negative to positive. Then sir, how is it positive to negative? It doesn't matter. I could move from negative to positive or positive to negative. The mere fact that there is a change in the signs suggests that I would have crossed over my exact root. So what we normally do is to look. What we normally do is to look at the values, and the values say x is 1, x is 2. So we'll find the midpoint, the average between the 2 points. So the average between the 2 points is 1 plus 2 is 3 divided by 2 is 1.5.
Hold on, sir. You hear me? So, Sean?
Yeah, man, I'm hearing you.
Yeah, man. That part there. Can I repeat that part? I think may get lost a little.
All right. So is I have x1 to be equal to 1.5?
Right.
Good. So this one, I know I can't use because this one, the value is -1. This 2, the value is 5. So I'm saying to you that my answer lies between 1 and 2. So I am hazarding a guess to say that I'm going to use 1.5, the midway point between the 1 and 2. I'm using 1.5.
Oh, okay.
All right. So I'm using 1.5. So that's why my first iteration is going to be 1.5. I'm making a guess for my first iteration to be 1.5. Now, if 1.5 is too far up, when I do my iterations, it's going to come back down. When I do my iteration, it's going to come back down. So when you look at it now,
when you say come back down, what do you mean?
See here, so 1.5, and then when I did my second iteration, it came up to 1.3478. So it says to me that my initial guess was too far up. So when I do my calculation, it carries me closer to what my actual answer is supposed to be. And then when I look at my third iteration from the second was 1.348. My third iteration is going to be 1.3252. So I'm getting even closer to it. Then my fourth iteration is 1.3247. So when I started at 1.5, I started too far up.
Yeah.
Right, but guess what? That's where I'm going to start. I'm going to start halfway between the two values.
Right.
So now that you have your first iteration, what we need to do now is to work out what our second iteration is going to be. But how to work out the iterations? We have to use, it's here. We have to use the formula. See if I can find the formula. No, I have the formula in pink. See the formula here. The formula is x subscript n plus 1 is equal to x subscript n minus f of x subscript n over f dash of x subscript n. So you see the same value that you have right here, so? Is the same value when you substitute into the original function f, is the same value when you substitute into the first differential. You work out all of that to give you one value. So if this is x3, that means this is going to be x4 because this value is 1 plus this other value.
Wait, sir. Hold on. You see the part where you said this, hold on. These are the same question, right? That doesn't make sure.
Mm-hmm.
I know a different question is, sir.
I'm showing the formula, Maurice.
Oh, okay.
I'm showing the formula.
Okay. Well, you say, yeah, we'd use that formula. That comes in right there. Yeah, I see where it comes in.
Mm-hmm.
Yeah.
So there are two things that I'm going to be using to substitute. My original function f of x and the first differential. So at this point in time, you have to differentiate the function. At this point in time, you have to differentiate the function. And in differentiating the function, is x cubed minus x minus 1. When I differentiate the function, I'm going to get 3x squared minus 1. See it here, so 3x squared minus 1.
Right.
So in the original function, now x cubed minus x minus 1. Anywhere in that function I see x, I'm going to put my first iteration, which is 1.5. So see it here now. So the x here, so it becomes f of 1.5. Equals 1.5 cubed, see it right here, so 1.5 cubed. Minus 1.5, minus 1.5, minus 1. Put all of this into the calculator. and you should get 0.875. Try that for me, please.
Yeah, Mr. Sean,
Mm-hmm.
can go. Oh, show me never. You can go back on that, sir, please. Should
Oh,
I get?
you're not seeing it?
No, I see in the tab you switch. Yeah, this have a share for that tab.
Oh, you seen it now?
Yeah, yeah, man.
Okay.
All right, so I get the for the f of x, so 0.875.
Mm-hmm.
Do it for the other one here now.
You understand that? Okay, the other one you said, no? Cool.
All right, so yeah, I got those the 5.75.
Mm-hmm.
Um, 0.5.
Substitute that into the formula for me now.
Yes, sir. Yeah, so 1.347 3.348. Yeah, 3478. Yeah.
All right. Now, that now becomes my second iteration. Meaning now, I am guessing that it was 1.5, that the answer is, the root is 1.5. When I did the first iteration, I'm getting closer to the answer. It is saying to me, um, it never asked me it never asked me how many decimal places, right? But I'm getting closer to the answer. So because I can't say whether or not I'm going to get a bit closer, I have to do another iteration. Why? Because one answer is 1.5, then the other answer is 1.35 if you run it off to 2. So that's
Yeah.
too far off. So I have to do a third iteration now to see if I can get an answer closer to this. So when I do a third iteration, you recognize here the same f of x function and the same f dash of x function, see it right here, so, or see them right here, so, is the same function that I'm going to be using to do the substitution. The only difference is I'm not going to be using the 1.5 again because that was my first iteration. In order to work out the second iteration, I'm going to use now the value of the second iteration to work out the third one, right? So this 1.3478, I'm going to substitute it into the same two functions. The functions have not changed. Into the same two functions. And try that for me and tell me if you get the 1.3252 that I have down here.
All right, sir. Yes, I get that back, sir. The same
Good.
answer.
Good. So now that you've done this third iteration, you're now comparing and say, okay, the second iteration is close to the third iteration. But if I'm using two decimal places, watch what happens. This is 1.35. This is 1.33.
3.
Yeah, but we can get closer, man. We can get closer because if I really want to find the root, listen to me now. It's a 0.01 or 0.02. 0.02 can do a whole heap of something, because if you give a person 0.02 more exposed to radiation, it can kill the person, right? And 0.02, but 0.02 drops of plutonium into drinking water from NWC can kill off the whole of Jamaica. All right?
Yeah.
So yes, man. So it makes it very important for us to be very precise. So we're gonna do one more iteration and see if it gets closer to this 1.352. What I want you to do, we're going to find the fourth iteration. Remember, we're going to use the same function, the same primitive right throughout the question. But you are going to do the fourth iteration for me now and tell me what you get.
All right, sir. Yeah, man. Yes, sir. I get back that 1.3427.
1.3247.
Sorry, right.
Mm-hmm.
3247.
Now, if we go to two decimal places now, we go to two decimal places. Look at what will happen. 1.33 don't.
Yeah.
And this is 1.32.
2.
Mm-hmm. You want to do a fifth iteration for me? Do a fifth iteration for me. And incidentally, this question, well, you don't have to do a fifth one. Don't do the fifth one. So the question, I think, name. Rashim asked the question last class. So how many decimal places? And I said to him 3. So if you look at it now, 1.325.
Right.
1.324. But the decider now is greater than 5, so you can add 1 to it. So you get 1.325 up here. This decider, the 2, is less than 5, so we can throw it off. This decider 7 is greater than 5, so we can add 1 to this. So we can get 1.325 up top, and we get 1.325 down here. So we get our values. So guess what? 1.325 is a root of the this this
Okay.
function. Now, what I didn't show you guys last week, because it asked a question 1.325, because it asked a question, because it asks a question, what I want you to do, oh Lord, I'm trying to log on to another device to, all right, substitute that answer, the 1.325,
Yeah.
1.325, yeah, 1.325, I want you to substitute that answer into the original question up here, so, and see if you get 0 for your answer. Because when you get 0, it means that you get a root. Remember I said to you, you know, when you find the root, watch me. When you find the, oh, where it is. When you find the root of the function, the root, see there says exact root. The exact root is when you sit down on the line.
Okay.
So when you sit down on the line, it means that y equals 0 or f of x equals 0.
Right.
Anywhere
So,
this
so
line, go ahead.
that's what you're saying. So if that is really the root, then when you put it in that original form, you should get f of
0.
x equals 0 or y
Very
equals.
good. Very good. Very good. So go ahead and put it in for me until you get 0. Very nice.
That's the fourth, which iteration? The third iteration?
No man, your answer is going to be no. No man, your answer is going to be 1.352.
Yeah.
But I'm just showing you know how to check your answers to see that you're on the correct path.
Okay. So, Mr. Sean, so what I get is it would be 0.0012.
No, 0.00. Yeah, 0.1. Yeah. 0.12. Yeah. So which is 0.
Yeah.
Which is 0. So so you're saying now that you have found the root, right? So you're saying to me now that here the answer. This is the root of the function. That's the root of the function. So that's how we do our questions, and that's the main area of the iteration. This one was a little different from the others because the others they gave you what the first iteration is. This one they didn't. There's a multiple choice question that I had put on. I never went through it. Let me see something here. Or this was some differentiation. Yeah, I kind of think that I may need to go through some differentiation with you in order to prepare the Newton-Raphson, not the Newton-Raphson, sorry, Mclaren's. Let us look at this other one here. Example 6, it says the equation f of x is given as x cubed minus x squared plus 4x minus 4 equals 0. So you notice this one here has many more terms than this one here. This one has only 3 terms. This one here has 1, 2, 3, 4 terms. It says considering the initial approximation at x equals 2. The initial approximation at x equals 2, meaning that my x1, my first iteration is going to be 2. So they're telling me that it's going to be 2. I didn't have to work it out like I did for question number 7. Question number 7 didn't tell me, so I had to work with the iteration. This one, they gave me the iteration to say the first one is 2. And then the value of the next approximation correct to 2 decimal places. So the question is now asking me to find the second iteration. I don't want to go any further than the second iteration. It's a multiple choice question. So give me the first iteration. The man them say, here the plan. Go ahead, find for me the second iteration. I want you to do that. And for those others who come to class and don't even say good afternoon, yes, you too can go ahead and do it. Start with number 6, please.
Right, sir.
You see, when I give students work and students are so quiet, I mean, now you're nothing from students, we get very worried. What's the answer? Anybody get my 1.33? Hello?
All right, Sarah.
Yes, Papa.
Yeah, man. I was making some notes for number 7
Mm-hmm.
in time, so I don't get to touch number 6 yet because I don't want to get the things that you showed me for number 7.
Mm-hmm.
I had to be just writing down some stuff.
Okay, no problem.
Yeah.
Alright. Harp and write those down. Remember, you're still going to have the recording available to you, so you'll still hear what it is that I said. So harp and write it down because I don't want you to have a thought now and miss it. And when you read the recording, you don't remember that thought. So with the thoughts, write down the thoughts and see if we can go to that because I want to move into another application. As I said before, it's a fast track class. And so in the school year, I will reach yours already. I'll be doing some other stuff, but it's a fast track. So I'm looking for the main points first, and then I'm going to put the fillers thereafter.
Okay.
So it's like me having a big container and just putting in the rocks first, and then throwing the sand after, and then throw the water. Because if I put in the water first and then put the rock, I'm going to spill the water. You follow what I'm saying? So I'm
Yeah,
putting
man.
the big stuff first, and then just putting the fillers in between. Yeah. The rest of you, no, so good afternoon. I'm saying must do the work. You not finish the work yet.
All right. Well, we're on it now, Sarah.
No problem. Miss Davia, Mr. Ramesh.
Yes, sir.
Afternoon, sir.
Me understand, Uno. You do the work yet?
Sir, I did do something in the
I swear I
kitchen.
think these are from last class.
No, more want you do. We never do question 6, man. Do question 6. Davia, top tell lie. You can't cook, but you're in your kitchen. Come on, tell us. You can cook, Davia?
Yes, sir.
Tell me the biggest food you can cook.
I can't cook dinner. I'm gonna make money tomorrow, sir. So me in the kitchen, sir.
Oh, okay. They're going to make mutton tomorrow.
Yeah.
Father, I pray for them. Even before they eat it, Lord, in Jesus' name.
Wow. What you doing now?
No, follow the teacher here, Davia.
I'm gonna try to do the question now.
Yes, thanks, please. You can go on multitasking, but I want you to just make sure you get the stuff out of the way.
So I get it.
Very nice. Very nice. I'm very happy for you. All right. Ramesh, how you stay? How you stay? Maurice.
Still our work, sir.
All right.
Yeah, I didn't get it too, sir.
Negative.
Yeah, man.
Nice. Very nice. Ramesh, I think you have about 2-3 minutes more to work on the stuff. Even though it's a fast track, I don't want to move too fast so that I go through the syllabus again and you still don't catch it and still don't pass the course. The aim is to pass the course this time. So I'm going to give you a few more minutes. Then I'm going to do one more topic in Unit 1, which is Mclaren's expansion. And hopefully I'll have enough time to touch on one of the topics in applications under integration. So what it is that we're looking at are applications under differentiation. I want to look at applications under integration after, just do some stuff and, just play around, as I said before, with some of the areas. So, yeah, so just go and look at that. Or Ramesh. And some of the fillers that I need to look at is the differentiation. Because if I'm doing the applications of differentiation, they can give you functions to differentiate. So, if you don't know how to differentiate the function, you're kind of dark. Or if you differentiate the function incorrectly, it means that try as you may, the answer is not going to be correct because your differentiated function is incorrectly done. So one of the things I keep saying to students is when you differentiate the function, double check to make sure that you have correctly differentiated the function. And then I'm moving to doing the questions thereafter. We want to maximize on the points here. So 2 more minutes and then you can look over in the meantime, 2 more minutes and then we'll move on. Finish, Ramesh?
Yes, sir.
Or you stay? All right.
Yes, sir.
All right. Let me see if I can just get some. Hold on. All right, hold on here. Okay, my system was giving some problem. The document open. Hold on. I'm generating a document to send to you in WhatsApp, and then we just go through the document.
All right, sir.
Wanna get it?
Yeah, I see it in the group, sir. We download it now.
All right, no. So I'm using my original device has decided to act up. So I'm using another device, and so that's why it took me so long to do it. It's a borrowed Chromebook sort of something, so I don't have my software that I normally type up and do the stuff on it. So that's why I have to be a PDF in the document and send it on WhatsApp. So I'm actually using WhatsApp to open the document to teach from it. So bear on it here. Have to make good of a somewhat bad situation. All right, so my question to you now is, are you feeling a little bit more comfortable with Newton-Raphson?
Yes, sir.
Mm-hmm.
Yes, sir.
Nice. Davia?
Yes, sir.
Okay, thank you, please, miss. All right, so right about now, I want to shift some attention to Mclaren's theorem. And hold on a minute, please. Okay, so looking at the are you still seeing the screen?
Yes, sir.
Good. We're finishing Mclaren's in class today here. So we want to start even one of the applications of integration. So work with me. Give me about 5 minutes undivided attention now, and then we can chop it up after. So Mclaren's formula is f of x is going to be equal to f of 0 plus f dash of 0 x plus f double dash of 0 over 2 factorial x squared plus f triple dash of 0 over 3 factorial x cubed plus dot 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 plus f to the n of 0 over n factorial x to the n. Sir, My loss. No, you don't have to be. Work with me. Let us look at the pattern. F of x is equal to f to the 0, f of 0 rather, plus f dash of 0x plus f double dash of 0 over 2 factorial x squared. Oh, sorry, hold on. The first differential with 1x. The second differential with x squared. The third differential with x cubed. But hold on, sir, I see something else. The second differential over 2 factorial. So everything at 2. 2 up here, sir. 2 down here, sir. 2 over here, sir. We could try it again, sir. 3 up here, sir. 3 down there, sir. 3 over here, sir. So we could try the general formula. N up here, sir. N down here, sir. N over here, sir. Yeah. So take note. I'm trying to make the formula simple for you, because if you don't catch a formula, you're doing a problem. So watch what I'm saying. All of these are over factorials, you know. But it's just that 0 factorial is 1. And 1 factorial is 1. So all of these, and in all of them, when you find the differential, you're going to substitute 0. So you can go with the original function, f of 0 over 0 factorial, x to the 0. Anything raised to the power 0 is?
1.
1. Numero uno. Talk of truth. Numero uno. So this is f of 0 over 0 factorial, x to the 0. 0 factorial is 1. X raised to the 0 is 1. So I'm left with f of 0, the same thing like up here. So then plus f dash of 0 over 1 factorial, x to the first. X to the first is x. See it right here, so 1 factorial is 1. F dash of 0 divided by 1 is f dash of 0. And then the rest of them are the same because they're not changing those. 2 factorial over 3 factorial and 4 factorial, 5 factorial, all the way down to n factorial. All right? So you need to spend some time learning or memorizing Mclaren's expansion, the formula. If the formula is wrong, everything else is going to be wrong. If the formula for Newton-Raphson is wrong, everything else is going to be wrong. So you have to be very careful. Okay, let's go. That's all I wanted. Just enough time for you to soak in. So let us review factorial notation. N factorial is really n times n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 times n minus 6 until I reach all the way down until I get to 1. And in my general form, I'm going to call K1. So what am I saying? 5 factorial is 5 times 4 times 3 times 2 times 1. Really, sir? Yeah. 5 times 4 is 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is 120. Press pause. Grab your calculators. Look at your calculator and look for the exclamation sign on the calculator. Exclamation sign on the calculator. Look for your exclamation sign. When you find it, say, I found it, so I can move on.
All right, I find it, sir.
Good job. So, unfortunately, this system is not coming up. Let me try it one more time because I would have been able to use my emulator and show you what is happening here. All right, let me just close this out and then try again. Because it's saying that I'm not connected, but I'm very much connected. See? Connected. Right. So now, if for example I ask you to find 100 factorial, not that I'm going to ask you, but if I ask you to find 100 factorial, really and truly, it is 100 times 99 times 98 times 97 times 96, all the way down until I reach times 2 times 1. That's what 100 factorial is. We don't have time to do that. We have calculators. So again, juke it in the calculator and just press 100, then the factorial notation sign, press equal, voila, we get our answer. And that's how we do it. That's how we do it, right? Because when you're doing a question on Mclaren's expansion, is a long question in and of itself. So for me to go and ask you to manually calculate the factorials, it would be too much to ask. So make sure that you have a calculator. It is important that you own a calculator for this course. Not to borrow one before the exam, but to have one that you're going to be using in class. I'll be very deliberate in how I assist you in using your calculator. When I get into this, I'm going to show you what some students did for the exam that just went. Made some very careless mistakes with the Mclarens. Easy 5 marker, only few students got the full marks. Some students only got 1 mark and 2 marks. And I think most of them I gave 3 because I saw the error. But yeah, grave error. So let's go. So I have an example here that says expand 1 over x plus 1 up to and including the term x to the 5th. Rockstone, sir, what kind of question this? No problem. So because it says, and I want to relate it to the formula. It's because it says up to and including the term in x to the 5th, you recognize that x to the 5th, x to the 3rd corresponds to which of the differential? Which differential is this? X to the 3rd corresponds to which differential, class?
Third one, sir.
The 3rd one. And the 4th differential corresponds to x to the?
4.
Yes, man. So it go. Right? So the differentials correspond to the powers, and the powers corresponds to the differential. So the mere fact that it says up to and including the term x to the 5th tells me that I will have to differentiate this something 5 times. So much time, sir? Yep. So the first thing, I need to have my original function. And in my original function, I'm going to substitute 0. And when I substitute 0, I evaluate that. Then what I'm going to do is go through with the function, the first derivative, then the second derivative, then the third derivative, then the fourth derivative, then the fifth derivative. Again, why am I going up to the fifth derivative? Because it's a term including x to the 5th. It's a term including x to the 5th. I'm including the term x to the 5th. All right? So let's go. I am going to let f of x be equal to the function. I'm letting f of x be equal to the function. So could I don't just go ahead and just differentiate it? No. I'm going to differentiate it and name it. So I'm letting the function be equal to f of x. So you couldn't call it y. Anything you want to call it, to call it. Anything you want to call it, to call it. So I'm letting x be the f of x be the function. Very important to name the function, right? So this is what I'm going to have. F of x is equal to 1 over x plus 1. Remember now, we need to find f of 0. So anywhere in the function I see x, I'm going to put 0. So if this is f of x, so find f of 0, I just put in 0 everywhere I see x. So f of 0 is going to be 1 over 0 plus 1. 0 plus 1 is 1. So I have 1 over 1. 1 over 1 is equals to, see it over here, so 1. So I have evaluated f of 0 and I get 1. Watch me. I'm now evaluating f dash of 0. the first derivative and put in 0. Remember, then again have the second derivative and put in 0. Then the third derivative put in 0. The fourth derivative then put in 0. The fifth derivative and then put in 0. All right? So let us move on to the first derivative. It means that I have to differentiate this function. Differentiating a function, we're using the quotient rule. So why quotient rule? Because it's a fraction. Sir, how you do this, sir? The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Watch me. I cannot find the okay. I cannot find the animation to this, so I'm just going to use some blocks here. All right, watch me now. It's the denominator. It's the denominator right there, so. And I put it up here, so. Whenever I call it, I put it up here, so. So that's it. Right there, so. Okay. This is not working out. Not working out. It's not happening. All right. Work with me. I'm on the second page. I'm at the top of this page here. I'm at the top of this page. So I'm saying the denominator, I'm using this piece here at the bottom here, f of x to differentiate it. It's a denominator, x plus 1. I put it in the numerator here. Are you seeing the cursor here on your screen?
Yes, sir.
Yes, sir.
Okay, great. So it's a denominator, x plus 1, see cursor, times the differentiation of the numerator. The numerator is a constant, so I call it 0 when I differentiate it. So anytime you differentiate a constant, you get 0. So it's the denominator times the differentiation of the numerator, which is 0. So the 0 here. This dot don't mean point or full stop. It means multiplication. Big school, we use dot for multiplication. All right. So it's the denominator, x plus 1, times the differentiation of the numerator, which is, I get a 0, minus the numerator, so it's minus the 1, times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1. How, sir? When I differentiate x, I get 1. When I differentiate positive 1, I'm going to get 0. Remember, the differential of a constant equals to 0. So the formula says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. That's the part to reach now. All over the denominator squares. All over this x plus 1 all squares. Then, sir, if we go sit down and expand this, no, never. Never, 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 never. So what I'm going to do now is to kind of fix up. Finish with that piece. What I'm going to say is x plus 1 times 0 is 0. Minus 1 times 1 is minus 1. So you see, I have this minus 1 right here. So see, I have the x dash. The dash means that is my first derivative. Single dash is my first derivative. Double dash is my second derivative. And triple dash is my third derivative, so forth and so on. So I'm going to have -1 over the denominator. Sir, do we expand the denominator? Never. Don't get into the habit to expand the denominator. Leave the denominator as it is. We're good?
Yes, sir.
Yes, sir.
No, when we find the first
Before.
derivative, we are going to substitute 0 into it. So anywhere in the first derivative I see x, I'm going to put 0. -1 over 0 plus 1, the denominator work will be 0. So I'm going to have -1 over 1, which is equal to -1. See it right here, sir? F dash of 0 is -1. F dash of 0 is equal to -1. Let me pause. I sense in my spirit that somebody is not understanding. Are we okay?
Yes,
I am
sir.
so far, sir.
Mm-hmm. All right, find the second derivative for me now. Remember, in order to find the second derivative, you have to use the first derivative. In order for you to find the second derivative, you must use the first derivative. So go ahead and find the second derivative for me, please. If you're stuck, shout me right here.
Sir,
Mm.
I can't do it.
What happened?
So I don't know.
What difficulty you have? Talk to me, Trish.
Sir, I have x plus 1 squared times 2, and then I'm stuck, sir.
The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares.
So I'm going to square the square.
Yes, ma'am. Yes, miss. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares.
What happened with that movie? My tattoos.
Yeah, what Saturday Martin need to do? Turn on that for me, please. All right. So look at what I did. I introduced it to the power rule. And if you don't understand these rules, just let me know so I can generate some stuff and send to you. Maybe it's a fast track, so you have to learn something fast. I'm not in the school here where I can take my time to make it digest. We are wrap it up with something, all right? So this piece here is my f dash of x. So what I'm doing here now, I'm trying to find the derivative of f dash of x. So I'm converting this into x plus 1 to the negative 2. Sorry, negative x plus 1 to the negative 2, because the law of indices says a to the m raised to the n. Wrong law. The law of indices says 1 over a to the m is equal to a to the negative m. 1 over a to the m is equal to a to the negative 1 over m. So once I have a rational function, meaning that I have a fraction, and I have one of the terms written as index, I can take it up into the numerator by reciprocating. So all of this x plus 1 all squares now become x plus 1 all raised to the negative 2. See it right here, so. All right. But what I did right here, mosquito go. What I did right here was also show you the differentiation of my x plus 1. So let me start with it on here. You don't have to look at this piece here. That's just a recall of the power rule. So see the function here. Watch me. This function f dash of x is equal to negative 1 over x plus 1 all squares is the same function as I have here. I call it a recall. Showing you that because I'm moving the screen. Watch me. The denominator, x plus 1 all squares, see it here, so, times the differentiation of the numerator, differential of the constant, negative 1 is 0, minus the numerator, negative 1, see it in here, so, times the differentiation of the denominator. See the denominator inside here differentiated. Let's go. This 2 is going to come in the front, this x plus 1, see it here, 2, x plus 1. But I must multiply by the differential of the inside of the parentheses. So I'm looking at inside of the parentheses and I'm seeing x plus 1. So I'm finding the derivative of that. When I differentiate x, I get 1. When I differentiate plus 1, I get 0. The differential of a constant is equal to 0. The differential of a constant is equal to 0 every time. So therefore, all of this goes to 0, you know. X plus 1 squares times 0. All of this goes to 0. And then I'm going to be left with negative times a negative positive 2 times x plus 1 over x plus 1 to the 4th. But this x...
The denominator where you have x plus 1 to the 4th, then to the 3rd. Where you get the 3rd?
Alright, before that, you see why I get the 4th? Because it's a denominator squared.
Yes.
Got it. So in the numerator here, I have 1 x plus 1. And in the denominator, I have all of 4 of them. So to make my function easier to work with, I'm cancelling out everything, all of the x plus 1 in the numerator, and I'm cancelling one of it from the denominator.
Oh, okay.
So I'm going to be left with x plus 1 to the third. And this will be my final differential. That will be my final differential. And then now, having had a final differential, I'm going to substitute 0 into the function. All right? Okay. So having identified the second differential, anywhere in the second differential I see x, I'm going to put 0. Anywhere in the second differential I see x, I'm going to put 0. Remember, when we work with Mclaren's, every one of them, when we say 0, after we're done differentiate, we're going to put 0. Okay? So it's going to be 2 over 0 plus 1. 0 plus 1 is 1. 1 cube is 1. So it's going to have 2 over 1, which is 2. Which is 2. All right. I want you to work through these for me. 3, 4, and 5. I'm right here, so. But I want you to work through and see if you understand what I have there written out for you.
Sir, before you go, just the last part of what you said, how that 2 come about again?
Oh, because what is happening here now, I'm going to have all of this here goes to 0. Because x.
No, hold on, not there, sir.
Right here, sir?
No, to the
This
left.
goes to?
Yeah.
Oh, I put in x equals 0.
Oh,
We're finding f of 0. And see here, f double dash of 0, f triple dash of 0, f to the fourth dash of 0, f to the fifth dash of 0.
okay.
Come on.
Okay, all right, sir. All I know.
Give me a minute. right, so if you're having any difficulty, please don't sit down and walla into it. I want you to talk to me so we can work it through. I beg of you.
All right, sir.
Mm-hmm.
But they kind of lost me, you know.
Which one?
All right, the we call it again. The if
Triple dash or double dash?
triple dash, right?
Mm-hmm.
So all right, I realize the trend that like the pause before the but me no want just do it that way.
Absolutely, because you have to first do the differential. Russia, I went for something to drink and left it in the kitchen. Miss Smart, don't. Oh goodness. Yeah. Yeah. You will see the trend after you do the stuff. So you have to do the differentiation first. Then you will see the trend thereafter to know whether or not, to give you an idea whether or not you're right or wrong. So let me go.
Oh.
So we're using the second differential in order to arrive at the third differential. We're using the second differential in order to arrive at the third differential. So watch me now. The denominator, x plus 1 to the third, see it right here, so x plus 1 to the third. The denominator times the differentiation of the numerator. When I differentiate 2, it's a constant, so I get 0. That's why I have this 0 here. Minus the numerator, minus the 2, times now the differential of the denominator. Watch me. X plus 1 cube. This 3 comes in front. Then I'm going to have x plus 1 to the second. See here? 3. Then x plus 1 to the second. And then times it now by the differential of the inside of the parentheses. When I differentiate x, I get 1. See it right here, so. When I differentiate this one, I get 0. So the differential of what is inside the parentheses is going to be equals to 1. All over the denominator squares. But here, so, is x plus 1 cube. So we're going to have x plus 1 cube squared. So the law says a to the m raised to the nth power is a to the mn. So when I multiply this 3 by the 2, I'm going to get to the 6. All right? And
No,
then...
Hold on, sir. Hold on. The last part. The last part.
The differential part for the denominator?
Yeah, man.
So it's when I squaring a function, when I'm squaring a function, x plus 1 to the third power, all squares, okay, I was wondering why I couldn't get it like that, right? So what I'm saying to you, What if I should have shut down that system? What I'm saying to you is, when I have x to the third raised to the second power, the law of indices said that I'm going to multiply this by this. So 3 times 2 will give me 6. So what I'm going to end up with now is x to the 6. Follow, Maurice?
Yes, sir.
Yeah, good. So that's how I end up with the x to the 6 right down here. So, but
So I have a question, sir.
go ahead.
So like how it was before you did cancel it before they get the third x plus 1 to the third, they cancel the x plus 1 in the denominator with one of the x plus 1 in the denominator.
From the numerator.
Yeah, I was thinking like since it was like 4 and you keep on squaring the denominator, wouldn't it be like you just adding 2 consistent the same way for the denominator?
Yeah, and that pattern comes up when we would have done the stuff, but we know the pattern because the functions will not always be 1 over x plus 1. So it's not until you see all this pattern that Maurice saying, see Ramesh, all this pattern right here, so it only comes when you have done the differentiation. So it's not that you know what is going to happen to say, okay, we're just going to add 2 to the power. Don't work like that. It's after we've done it, then we see the pattern, and then we can know whether or not something is out of sync. So it's like you see five girls in a plaid uniform. 4 of them in one of them in a different one. So you say, okay, yes, 1 Meadowbrook, 1 Meadowbrook. No, man, it's a Camperdown. Then it's another Meadowbrook. Then it's another Meadowbrook. So you may say, no, but something is that. And they say, oh, but you're sister schools, right? So you're looking, you're not going to be able to differentiate until you look closely at it.
Okay, sir.
So when it,
so like how you did cancel in the first one, the second.
I'm hearing you. Go ahead. Hello? Hello? Anybody else hearing? Or is my internet gone?
We're hearing you, sir.
Ramesh, you're saying something. How Ramesh are talking to play stuff is so? Ramesh? Oh, all right, in gone. All right, oh, he got cut off. He's back now. He's coming back now. All right, go through, brethren.
Terry, change
the screen.
Forgive me here. What a good thing that I am a decent person. But if I was looking at something else, oh my Lord, give you thanks. Yeah, man. So, anyway, what's that a while ago? Okay. So 1, 2, 3, 4, 5, 6. Alrighty. Ramesh, you answered the question, Papa. You got disconnected. You waited on you. What's up?
Okay, so I was asking, you cancel in the second derivative, but you didn't cancel it in the others. Why is it?
I sure did. Watch it. It's because you don't want somebody to draw the line, so watch it, man. You remember, so this is 0, you know, because x plus 1 to the third power times 0 is 0. So I'm going to be left with x plus 1 squared, and x plus 1 squared, and this is x plus 1 to the 6th. So 2 of these will be moved, and then I reduce this by 2. See there? X plus 1 to the 4th.
Oh,
Yeah, man. And then now, if you look at this, all of these that I put in blue is to show you that it went to 0. So I have x plus 1 to the 3rd, and when I subtract it from this, technically, because remember the law says when I'm dividing, I'm subtracting my power, the numerator minus the denominator power.
yeah, that's
All
right.
right, good. So when I remove 3 of them from here, so I'm going to be left with x plus 1 to the 5th. See it right here, so? When I remove 4 of them from this, then we're going to have 6. See it right here, so? So yeah, man, that's what I'm doing. I'm actually doing the cancellation. So let me just do one more of the differentiation from the 3rd to the 4th. This is the 3rd, and I'm trying to get to the 4th. The denominator, x plus 1 to the 4th. See it here, so? Times the differentiation of the numerator. Hold on. All right, guys. So, so it's the denominator, x plus 1 to the 4th, the denominator here, times the differentiation of the numerator. Now, the numerator is 9 or 6. When you differentiate a constant, you get 0. See it right here, so you get 0 right here, so. Minus the numerator, so it's minus this up here, so, which is negative 6, times the differentiation of the denominator, which is 4 in front of here, x plus 1, I will reduce it by 1, so you're going to get 3.
Sir, where is the mouse?
You're not seeing it? Talk to me now, you're not seeing it?
Oh, sir.
Oh, Rockstone. All right.
Yeah, seeing
Yeah,
it now. I just see.
You see it now? Yeah, I don't know. Sometimes it appears and then sometimes it just disappears. All right. Let me see if I can. I need to shut down my other system, my preferred system, and see if I can get it. I'm just not connecting to Zoom at all from the other one. So are you seeing it now? Still seeing the mouse?
Yes, sir.
All right, good. So it's a denominator, x plus 1 to the 4th. The denominator, see here, so, times the differentiation of the numerator. When I differentiate the numerator, negative 6, I'm going to get 0, because the differential of a constant is equal to 0. Minus the numerator, which is negative 6, see it right in here, so, times the differentiation of the denominator. Now, watch me. The differentiation of the denominator is we're using the power rule. So look at what happens. The 4 here, I will come in front of the 4 here, so. I'm going to have x plus 1, reduce it by 1, so it's going to be to a third power. But I have to differentiate what is on the inside of the parentheses. And when I differentiate x plus 1, I'm going to get 1. So watch what I can have. This 4 come in front of here, so see it here, so. Then this is going to be x plus 1 to the third power. See it in here, so. Times the differentiation of what is inside here, so. See it here, so. All over the denominator squares. X plus 1 to the fourth squares. 4 times this 2 in other squares going to give me 8. See it right here, so. Pressing pause and asking, are there any questions before we simplify it?
Sir, you can say the formula again.
The denominator times the differentiation of the numerator
And the differential of the numerator.
minus
Numerator.
right times the differentiation of the denominator all over the denominator squares. So the formula says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares.
Thanks.
No problem. All right. You look at the fifth one for me, please. The fifth one, and tell me if you can move from this into this.
Got it, sir.
Good job. What about the rest?
Working on it, sir.
All right, good. I'll wait on you.
Sir, oh you say you get the powers, the difference in the powers again?
I cancel it out. I cancel it out.
From the first one, how you cancel it out, sir?
So this is x to the third. So all of this can go into this and leave 5 times remainder under here. Talk truth.
X to the third, that's the one on the top.
Very good. How many x plus 1s do I have in the denominator? Say 8.
Just one. 8.
Right. And how many x plus 1s do I have in the numerator?
3.
Good. So that means that I can get all of them 3 here, can cancel with 3 of them down here. So talk truth.
Mm-hmm.
And how much are we have left down here? How many x plus 1s are we have left down here?
5.
See, Tessa? Magic. 5.
What ceremony you did from the first one?
Up here, sir? How many x plus 1s do I have up here, sir? So 1. Good. And how many I have down here, sir, originally?
2.
No, sir, 4.
Sir, how you get the 4?
Because see here, sir? Because this x plus 1 all squares, then give me x plus 1 to the 4th. So this one we can cancel with one of the 4s on here, so we have 3 left. See it right here, sir? Yeah? No?
I still not get to get the 4.
I get a 4 from here. Remember the question started from up here, so you know, x plus 1.
Mm-hmm.
Denominator squares. So that means I have to go square x plus 1. So when I square x plus 1, I'm going to get x plus 1 all squares. Talk truth.
Yes.
Yeah. So see here, x plus 1 all squares. And when I square x plus 1 all squares, square, I'm going to get x plus 1 to the 4th. Don't.
Okay.
See here, so x plus 1 to the 4th. But I have an x plus 1 up here, so. So since I have 4 x plus 1s in the denominator, and only 1 in the numerator, the 1 in the numerator will cancel with one of the 4 x plus 1 in the denominator to leave only 3 of them. You see it?
Yes, sir.
Good job. And so forth and so on. 2 more minutes to look at that. And then I go and explain what is in pink. Or which is that we put all of them together to get our final answer.
Sir.
Yes, Olive.
Hey, get where you get the 4. X plus 1, 4. Minus the one at the top, leave 3. Or you get the 6 next.
With 6. This 6 here, sir?
Yes.
How many x plus 1s I have up here, sir?
2.
Good. How many I have down here, sir?
6.
Oh, you say you don't say, oh, I get the 6 here, so that's what you're saying?
Yes.
Okay, this is x plus 1 to the 3rd squared. Remember, you know, it's always denominator squares, you know, when using the quotient rule. So when I square x plus 1 to the 3rd, I'm going to get x plus 1 to the 6th. Because this 3 squared is not, we're not squaring to get 9. In the c, sir, we're going to multiply. So it's 3 times 2, 6. That's how we get the 6. And then we cancel out and get to 4. 4 times 2, 8. So the 8 here, so. And we cancel out and get 5. 5 times 2, 10. So the 10 right here, so.
Which two you multiply the 4 by? The
Which-
numerator one?
The denominator squares. The denominator squares. All right.
Oh, okay, I get it.
You get it now? All right. I'm going to see if I can work on getting this. I just need to close out some of these things that I was working on to see if I can restart this system where I can manipulate it a little bit better. All right, let's see if I can get this thing again now. All right, any questions so far? I'm actually waiting on you guys to talk to me while I try to log on to another device. Any questions? Something you're not seeing? Let me know, you know. Or I can move into the last part of the stuff. You talk to me, no man. I hate asking questions and everybody does not responding to me. What if when you ask me a question and I don't answer you? You don't feel nice, man. Talk to me.
Sir, I'm all right so far. Now I get the last one, if the F5 one.
Okay, all right. So go on to doing, and then I'm here. I just want to go through the final part of the answer.
All right.
Oh, Rashim said that he has a funeral today. Oh, that's why I'm not seeing him. Okay, that makes sense. All right, so you're answering the question, and maybe because I didn't do this. Come on. So look at what I did right here now. Similar to what I did right up here, so I cancel out this 6 with this 2 to give me 4. Because remember, all of this goes to 0, you know. All of this piece goes to 0. Let me put it in a different color. All of that there goes to 0. So I'm only going to be left with x plus 1 squares over x plus 1 to the 4th. Now, let me do a recall here for you. Watch this here now. It's written to it to be pasted. All right. A raised to the m power, which is in turn raised to another power, is going to be equal to a to the mn. So 3 raised to the second power, and then multiply 3 by 2 to give me the 6. That is under here. Because a, let me spotlight. No, I can't spotlight because I'm using another system. A to the m raised to the nth power is equal to a to the m times n, mn. A to the m times n, mn. All right? So I don't know if that clears up anything a little bit clearer for you. It does? Yeah? No?
Yes, sir.
Okay. And I think she has. All right. Okay. So now what it is that I'm doing here is just putting everything together. That's my formulation. So I'm just going to substitute. My f of 0 is 1. So I can put 1 where my f of 0 is. See here, so 1. My f dash of 1, my f dash of 0, x is 2. My f dash of 0 up here, so lie. Oh, come on. Something is missing. Oh, see here. F dash of 0 is 1. f double dash of 0 is 2. This f dash of 0 here is 1. So and it's not just 1, but a negative 1. All right? So what is going to happen is that this number becomes a negative 1x. See it right here, so negative 1x. My f double dash is 2. My f double dash is 2. So this is going to become 2 over 2 factorial x squared. See it here? 2 over 2 factorial x squared. So all I'm doing is substituting my f of zeros. My f triple dash of 0 is negative 6. So where f triple dash of 0 going to go? So we're going to put negative 6. I'm going to change the negative sign right here. So and just put 6 over 3 factorial x cubed. So the negative sign change right here. So 6 over 3 factorial x cubed. My x to the fourth dash of 0 is 24. So I'm going to put f to the fourth over here. So as 24, the sign remains the same as plus. So it's going to be plus 24 over x of x to the fourth over 4 factorial. My f to the fifth is a negative 120. So I'm going to change the sign in the middle, and then I'm going to put 120 over 5 factorial x to the fifth. And then my other term is going to be positive. How do I know that, sir? Because you see the thing, it alternates. First one negative, second one positive. Third one negative, fourth one positive. Fifth one negative, it means that the sixth one is going to be positive. All right? Very important. My system is not responding. All right. So now I'm going to evaluate. 2 factorial is 2. So 2 over 2 is going to be 1. So I'm just going to have x squared. See it right here, so? 3 factorial is 6. So 6 over 6 is going to be equal to 1. So I'm just going to have x cubed minus x cubed. See it right here, so? 4 factorial is 24. So 24 divided by 24 is equal to 1. So I'm just going to have x to the fourth. See it here? 5 factorial is 120. We just did that. So 120 over 120 is just going to be 1. So we're just going to have negative x to the fifth. And that's what we have there. Can you take 2 minutes and look over this for me, please? While I go for my juice. Talk to me now. Are we okay? If you say yes, I'm going to give you one to try on your own.
Yes, sir.
Mm-hmm. Try example 3 for me. I send the handout in the group, but try and not look at the example 3, the solution to the 3 that I sent you. You can look at example 1 and see if you can do 3 on your own. If you're stuck, then you can look at the answer for 3. But I'm right here. Please. I really want you to do well, and I really want to get this thing before we leave out of class today. All right, so start working.
Sorry, you're going to start populating Edicosoft?
Say it again.
Edicosoft.
It's because today's your first class, but everybody else is on Edicosoft. I don't even know if them recognize that them on Edicosoft.
I don't see anything on mine, sir.
No,
I don't think
because you weren't here last class, so I didn't get your information.
Oh, okay.
So I'm saying everybody else is on Edicosoft. I don't even know if they realize this.
Sir, hold on, sir.
Sir, you can add me, please.
Mm-hmm.
Sir, I don't think I am on it, because remember I was the one on the road, first on the road.
Right. Um. Yeah. Oh, so Dave you recognize because Dave is on. All right.
Sir,
Yeah.
question. Will you get me to mess up for this class?
What do you think?
No.
Okay. You think I pay you no man? Come. Name for the Edicosoft, please.
Chanel with a C, Chennell.
Chennell.
Yes, sir.
C H
Allison.
Chennell .ALLISON. What's the number?
2014-1143.
The last number 43
Yes.
at my.ecc.edu .jamdown. Okay, Miss Chanel, you are there. Maurice, what's the last number? Last 2 digits?
10.
MAURICE FRANCIS 10 at my.ecc.edu.jm.
Am I supposed to be seeing anything, sir?
On what?
Edicosoft.
Yeah, man. You're on to Edicosoft now?
Yes.
You're not seeing anything?
No.
I don't understand. When you say not seeing anything, what do you mean? Are you seeing the
On
code that you're still?
tutorials or assessments, I don't see anything.
Or you may not see anything for assessment just yet because I only just set up it for you. I don't think I put on the assessment. Oh yeah, you're there. You're just log on. I'm seeing you. Um, Let me do the assessments now. Calculus 2. All right, you should see the assessments now.
I'm going to log out and log in again.
Just F5.
Can you see calculus on the dashboard now?
Mm-hmm.
Okay. Wow.
Let me know when you finish, I don't want to sit down there and not do anything.
Sir,
Yes, please.
I'm gonna lose marks if I not liquor down the fraction.
Mm, it is always nice when you share the mutton that you put little gravy upon it. Don't let that answer the question. But yeah, but I want you to just work it down into its lowest term and just shave it down. Yeah, man. And that's a very good question too, you know. Always very important to present our work in a manner where the man them can see clearly. We not make them to wonder what is it.
Sir,
Yes, please.
finish,
Mm-hmm.
but when I get what you get for the third one, sir.
Where you get?
You get 12, sir, not 16.
Hmm. Alright, so you got this 8 over 27, right?
Yes, sir.
Alright, let me start my differentiation from right here. The denominator, 2x plus 1 to the, times the differentiation of the numerator, which is 0, good, minus the numerator, which is 8, times the differentiation of the denominator, which is 3 times 2 plus 3 to the second times 2, all over the denominator squares, which is 2x plus 3 to the 6. All of this goes to 0. 2 times 3 is 6, and 6 times 8 is 48. 48 over the fourth, and that is 0. That goes to 0. 3 to the fourth is 81. So I have 48 over 81. 48 divided by 81. 16 over 27. No, man, that's correct. Look at it again, David. Yeah, no?
Yes, sir. I get it.
Nice. What about the rest of you? Oh my goodness. I'm just seeing a breaking news a while ago to say that the patient with that sort of new virus flees the hospital. Anybody saw that?
Yes, sir, I see it.
I joke something this.
Yes, sir, I saw it too.
What is going to happen to us? Talk to me.
It's a joke thing for
Well,
real.
spread.
Oh, I forgot to stay in, sir.
No, you see? Oh my goodness. Oh my goodness. No, this is so if they hold on upon him now, then we can charge him?
Yes, sir. I'm willingly infect people.
I mean, I know story. It wicked. No, why would you want to flee the hospital? And the hospital is a place where it is that you can have confinement, so it is that we don't. Hey, no, stop me. No,
He got pride in flee because he don't want the whole country to know say him carry come here. Cannot embarrass.
no, but listen to me. I know what. Well, all of us know what it's like going through COVID. Isn't the first part of COVID is nice? When we hear say 3,000 and 4,000 and 5,000 people that die every day in a one country. We're not about the other country. In a one country alone, you have 5,000 people dying in one day. Hello, 5,000. You know much. What is that? No, man. Can't. Lord help us. Can't do this again. You imagine those people who taking taxi and taking bus now? I forgot rubber on people. No, can't right.
But, sir, you can imagine that you're a big age, I get that.
Oh, Jesus, oh God.
It's still gonna look, you know.
You know, Davey, I don't even want to imagine. No, I can't. No, I can't imagine. And that's why I keep my horses all right, you know. I have no desires of taking another plane for now. Absolutely none. No desire. Jeez, some people. And push come to shove, we now go back on the more hotel. Because I decided that was where us do the hotels. But if them come now and we don't know and we end up sleeping at the same bed, let them stay in my yard. Oh Jesus, so don't can help us here. All right, what about the rest of you? The rest of you all right with it so far?
Sir,
Yes,
may I
sir.
gonna need more practice.
Yeah, I don't have a problem with you wanting to get more practice in Chanel. Don't have a problem. But we want to know, say, even if it take you a while to get it, but at least to get it, we're good to go. So tell me how you stay, Chanel.
Sir, may get it somewhat, but still I gonna need more practice.
All right, no problem. That's all I want to hear. Now, what about the rest of you? Deja, you sound like you're all right. Marie, so you stay.
I'm trying to sir, but no work out for me so far. For if the first one,
Mm-hmm.
yeah. Not sure what am I doing wrong there. So
I can't tell you what you're doing wrong. You're differential.
differentiation.
Yeah. You're not understanding it. It means that you're struggling with the differentiation.
Mm.
And this topic is applications of differentiation. So it means that you must understand the differentiation before you can really move into its application.
Yeah. So I have to do some. I have to do some work on that.
Yes, I. So we could press pause a little bit. So the topic is on applications of differentiation. So if our differentiation is not where it ought to be, we're kind of dark. Look at what I have there. The quotient rule, the denominator times the differential of the numerator minus the numerator times the differential of the denominator over the denominator squares.
Yeah. All right, sir.
Mm.
I get exactly to part will give me the problem. If you go back on question example 3, right? Um, no, example 3. All right. You see, if you call it again, if like 1 of x or
F dash of x.
dash of x, right?
Mm-hmm.
If all right, so I have the formula after that, right?
Mm-hmm.
But the part I have the problem with is when you work it out,
Mm.
because I thinking that um the numerator, the denominator and numerator would cancel out and would leave the denominator without a squared.
Mm.
Am I wrong?
Um. Yes, you are.
Okay.
So this is, I'm letting f to be the f of x to be equal to this function. And you remember I said to you that I need to find f of 0. So if f of s is here, I'm going to find f of 0. So f of 0 is anywhere in f of x I see x at 0. So I'm going to have 1 over 2 times 0, which is 0. So I'm going to have 1 over 3, which is this.
Right.
And then now, in order to find f dash of x, I have to differentiate the one before it to get this one here. Let's go. The denominator, 2x plus 3, see it right here, so.
Right.
Times the differentiation of the numerator, which is a constant, 0. Minus the numerator, minus 1, see it here, so. Times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 2. See it right here, so. All over the denominator squares, which is 2x plus 3 all squares. See it right here, so. Then all of this, 2x plus 3 times 0 is 0. And negative 1 times 2 is, see it here, so, negative 2. I don't have anything to cancel out the 2x plus 3 all squares, so I write it back.
Oh, hold on, sir. The part about, sorry, the numerator part, you can just go back over that part one more time.
Yes, please.
Start from, yeah, with working out that part.
Okay, so 2x plus 3 times 0 goes to 0. So everything here cancels.
Good.
You follow me?
Yeah, man.
I know it's there, so that's why you're asking if this could be cancelled with this down here. So yeah, so all of this goes to 0. Then I'm gonna have negative 1 times 2 is this negative 2 here. I don't have anything to cancel the denominator. Nothing at all to cancel the denominator, so I'm writing it back.
Right.
So I'm gonna have 2x plus 3 all squares.
It's follow you know.
All right. All right.
Thank you.
No problem, Papa. What about the rest of you? You good? I hear Chanel says she has to go look at it a little longer. Ramesh gone silent. Dave, you're okay.
Yeah, I'm good.
Yeah. All right. All right. I got that message, Ramesh. You are good to go. All right. Let us put all of these together now. We have our f of 0, f dash of 1, f double dash of 0, f triple dash, f to the 4th, and f to the 5th dash. So when we put them all together, this is our f of 0, f of 0 is, f dash of 0 is going to be negative 2 nines, which is here. F double dash is going to be positive 8 over 27 and negative 16 over 27. Then 128 over 81, then 1280, negative 1280 over 243, right here. So look at what I did. I put that there, then x. Then I put the x squared over the 2 factorial, which is the same thing, right? Same thing. X cubed over 3 factorial, x to the 4th over 4 factorial, x to the 5th over 5 factorial. Then I'm going to work out this times this 2 times x is 2x over 9. This thing here will work out because 2 factorial is 2. 2 cancel into 8 goes 4 times. So we have 4 over 27 x squared. Bam. 3 factorial is 6. Rockstone. So 6. So I can take 2 out of that and say 2 into 18 into 16 goes 8 times. And then we have 3 times 27 is 81. So we have 8 over 81 x cubed. And so forth and so on. 4 factorial is going to be equal to 24. 24 into 200. That divided by that will give me 16 over 243. And 1280 over 2443 over 243 times 120 will give me 32 over 729. And that will be the answer. I want you to try and evaluate that last piece of your own. The evaluation is what messed up some students last time around. I don't want nobody get lazy. I mean, and know that we are new into this in our as in our second class, and know that you are tired. So am I. I had 4 hours, 3.5 hours of teaching this morning, and class ended at 12, and I could only barely catch up to start you guys at 1. So I know the tide is real, but bear on. Yes, I am.
Sir,
Mm-hmm.
suppose I'm given one question where it can go down to the 5th iteration, sir.
No, well, on now. 2 different questions. No, this is not iteration. This is Mclaren's.
Oh,
If we can go down to the 5th differential.
yes, sir.
All right, no problem. They have some questions like that you can only go down to the 3rd one. So you just stop right there. So.
No, but may I say suppose them say if go down to the 5th one, sir. But
No, man, can't do that. I see your point. So if you can only go down to the 3rd one and them ask if we go down to the 5th, tell them say you can't do it. So you come do it. Joking, don't say that. They won't give it like that, David. Because they will know that you can't go down to the 5th. You follow me?
yes, sir.
Sir, how are you gonna know that?
Because when you differentiate, you end up with a constant. And when you differentiate that constant, you end up with zeros.
Oh, okay.
So you're gonna do the second example?
Is you waiting on now? Is you're waiting on to tell me so all right no. So I'm sitting right here waiting just to see. I thought somebody was still working. All right. Let me just read this one and just tell you something that you should know before I give you the last example. Well, not really last, but we can talk through something else. So if I say to you in example 4 to expand f of x to be equals to ln x using Mclaren series, I want you to all pay attention to this. A possible multiple choice question. A possible multiple choice question. When I differentiate ln x, the differential of ln x is 1 over x every time. When you differentiate ln x is 1 over x. So what will happen is the Mclaren series for ln x does not exist because the derivative of ln x is 1 over x, and therefore f of 0 is going to be equals to 1 over 0, which is undefined because it can't have a number that's being divided by 0. Look at that and tell me if you see what I said right there.
Yes, sir.
So I can't have 1 over 0 because 1 over 0 would be...
Hold on, sir. Hold on. Can you go through that again, please?
My pleasure. So I'm saying to you, if they say to me expand f of x is equal to ln 1 over x, when I differentiate ln x, I'm going to get 1 over x every time.
Right.
The differential of ln x is 1 over x. All right? Now, so the mere fact that I get ln x to be, the f dash of x to be 1 over x, I cannot find f of 0. Because f of 0 is going to mean anywhere in f of x, I see x, I put 0. And if I have 1 over x, it means that I'm going to end up with a 1 over 0. But I can't have a 0 existing in the denominator. So the first step is going to be undefined. And if the first step is undefined, the second step is undefined, the third step is undefined. All the steps are undefined. So therefore, all derivatives will be undefined in this way because you will be dividing by 0.
Okay.
Follow?
Yes, sir.
You can't be given a function with f of x equals ln x alone. It has to be ln x with something. So the x will be in parentheses with something. All right? Now, here goes a question. Like what it is that you're asking. It says expand this using Mclaren's. No, I can only differentiate this 3 times. So how you know? Because when I differentiate this first, I'm going to get 3x squared plus 2, don't?
Yes, sir.
All right, so I get 3x squared plus 2. When I differentiate this to get f double dash, I'm going to get 6x, don't?
Yes, sir. And none else.
And right, I'm going to differentiate 6x, I'm going to get 6 and then nothing else. I can only get 3 derivatives. I can't go to f4.
Yeah.
So because of that, now I know they don't have to tell me how far to go because we know say it will go done somewhere soon. Are you seeing that, Ramesh? You were asking when did you ask a question?
Yes, sir.
Right. So that one just tells you exactly where to go. And let me just finish off this one and then I give you another one to do. So since we go through all the differentials already, remember, you know, Mclaren's, these are applications to differentiation. So because I go through Mclaren's and differentiate this very quickly, now I just need to substitute and find f of 0. F of 0 is going to be -1. This goes to 0, that goes to 0, and -1. See here. F dash of 0. F dash of 0 is right here. So f dash of 0 is 2. Because all of that goes to 0, so it's 2. F double dash of that goes to 0. And look at this one here now though. f triple dash of 0, there is no x to substitute, so it's just 6. It's just a constant 6. So we can leave the 6 as it is here, like this. All right? And then Mclaren's now are going to put negative 1 plus 2x plus 0 over 2 factorial x squared. And remember, these tell us that we're talking about x to the first. This one say x to the second. This one say x to the third. So already you know that's matching up. So it's going to be 6x to the third over 3 factorial. How you know it says 3 factorial? So because that's something here. See here? That 3 here correspond with that 3 here, correspond with that 3 here. That 2 here correspond with this 2 up here, so correspond with this 2. Now 1 here correspond with x to the first and correspond with that imaginary 1 under here. So that 0, well, not 0 really, but yeah. So this term goes to 0 because 0 over 2 factorial is 0. So I don't have an x squared term. And then when I evaluate 3 factorial, I'm going to get 6. And 6 divided by 6 is 1. So I'm just going to be left with x cubed. So my answer is right here. 1, 2, 3 terms. I don't have to tell us to go up to x to the third because guess what? That's the only place you can go up to. You can't go x to the fourth. The fourth differential will give you 0. Fair enough?
Yes, sir.
Good. Good, 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 good. I want us to all right. All right, so what I'm going to do is give you this one to do. We're going to work through this one. Example number 7. And good thing you don't have this example with you. I'm going to work to the first piece with you. No, I'm going to work up to the second piece with you. And then ask you to do the rest. It says find the Mclaren series for the function f of x is equals to ln 8x plus 3. ln 8x plus 3. Up to the term in x to the 5th. Okay. So it means that I have to differentiate this in 5 times. Okay, got you. So that's the first thing, because I'm going up to x to the 5th. So because I'm going up to x to the 5th, I can tell you that the Mclaren is going to be f to the 5th of 0 over 5 factorial times x to the 5th. Talk truth.
Yes, sir.
Mm-hmm. X to the 4th is going to be x to the 4th is going to be f, the 4th derivative of 0 over 4 factorial x to the 4th. So it's easy to remember, very easy to remember. So that's one thing down. Number 2 is that we need to now differentiate the function. Differentiation is what is going to kill us. But we now need to differentiate the function. The differential of ln x is 1 over x. Hear me out. Hear me out. And for those of you away from Chanel and Maurice would know that this question here that we're looking at is something similar that came on the paper. And it so happened that the same question that came on the exam paper was somehow on the mid-semester. Nobody got full marks. Either place they did it. Because people are messing up the differential of the ln function. The differential of ln x is 1 over x yesterday, today, and tomorrow. The differential of the ln function is 1 over x. So the man them said to you, say, it is f of x is ln 8 minus 3. When I'm differentiating, this is going to be 1 over 8 minus 3 times the differential of the inside here. See it here? 1 over 8x plus 3. I said minus, supposed to be plus. 1 over 8x plus 3 times the differential of what is inside 8. So it becomes 8 over 8x plus 3. And that was the problem. Nobody was differentiating the inside of the stuff. So from the start, the question wrong.
Sir, repeat that, please.
Then you are differentiating the ln function. The differential of ln x is 1 over x. But you also have to differentiate on the inside. So it says the initial one is ln 8 plus x. Sorry, ln 8x plus 3.
Yes, sir.
We're finding f of 0. So anywhere we see x in the function, we're going to put 0. So this 8 times 0 is going to be 0. So we're just going to be left with ln 3. So this is our f of 0, ln 3. Easy 1, 2, 3. Everybody will get that in the paper too. But when we're differentiating this function, no, the differential of ln 8x plus 3 is going to be 1 over 8x plus 3 times the differential of inside the parenthesis. So 1 over 8x plus 3 times 8 gives me 8 over 8x plus 3. Look at that.
You lost me there, sir.
You know, I know y'all don't get lost.
Yes, sir. Why?
I know y'all don't get lost. Mm-hmm. All right. So f of x is equals to ln 8x plus 3. I'm differentiating f dash of x. The differential of ln x, the ln function is always going to be 1 over the function. 1 over 8x plus 3 times the differential of what's on the inside. The differential of 8x plus 3 is going to be 8. So all of that now becomes 8 times 1 is 8 over 8x plus 3. Yeah, no?
Yes, sir, I get it.
All right. Second derivative. I have to use the first to get the second. No one have a quotient. The denominator times the differentiation of the numerator, a constant, 0, minus the numerator times the differentiation of the denominator, differential of 8x plus 3 is 8, all over the denominator squares. 8x plus 3 all squares. That goes to 0. So all I'm left with is 864 minus 64 over 8x plus 3 all squares. Then I'm going to move to f triple dash. The denominator times the differentiation of the numerator, constant 0, minus the numerator, minus 64, times the differentiation of the denominator, which is going to be 2 8x plus 3 times 8. This 2 comes in front to get this. Reduce the power by 1, so it'll be 8x plus 3 to the first. I don't have to write it. And when I differentiate the inside here, so we can get 8 all over the denominator squares. 8x plus 3 square. And the denominator going to be equals to 8x plus 3 to the fourth. All of this goes to 0, because 0 times all of that is 0. So this works out to be, 2, 8, 16. 16 times 64 is how much? 1024. So that works out to be 1024 all over. No? Yeah, and this cancel, that 1 cancel into this, leave 3 times over 8x plus 3 to the third. See it there? Follow me so far?
Yes, sir.
Yes, sir.
Yes, sir.
All right, do me a favor now. I don't want to do the question. Come in now to do the question, you know. You will hear F of 4 to do for me, please. Start. When it's stuck, I can pull you up. Start.
Sir, you can scroll back up. Let me see the working out. Let me just get it off, please.
The one that I wrote a while ago?
Yes, sir.
Okay, no problem.
Sir,
Mm.
which one is I was supposed to do now? I just finish writing up.
Find f of 4 and f of 5, the fourth and the fifth derivative.
All right.
Mm-hmm.
Something will finish.
Finish? All right. No problem. What you got for f? The fourth derivative.
Do
What you got for the fourth derivative?
negative 24,576 over 81. So I don't know if right now the number look too big. All right.
You got the negative 24,576. Very good. Excellent. When they said 81, why put 81? Oh, I see why I put 81. I see why I put. You remember you asked me the question earlier?
So I actually click down, you know, but I couldn't find the.
No, man. Lick it down, say me, mommy. Very nice, but lick it down. What do you get for the fifth one?
Why, sir? I never click down, you know, so.
Tell me again.
786,432.
All right. Okay, good. You're on top of things. The only thing you have to work on nowadays is lickling it down.
Okay, sir.
Very nice. The rest of you continue working, and then somebody will say, "Sir, are them big number you going to get into the exam?" No.
So for the fourth one, is it that it liquid down to
Negative 8192 over 27. Get that?
repeat, sir?
Now I'm saying when you reduce it, we're going to get negative 8,192 over 27. Because what we really have is negative 24,576 over 81. But when you reduce it, you're going to get negative 8192 over 27.
Oh, I get the 8192, sir. But me never think for liquid on the 81.
But you're going to get 8192 and you can't work with one without being the other. You have to work with the two of them together. So you have to work with two of them together. You can't just reduce the numerator alone without consulting the denominator.
And you said the fifth one can be liquid down to as well.
Yeah, man. Yeah, man. And incidentally, the topic is finished here, yeah?
Sir, can you scroll up a little bit, Mrs. Something, to the fourth one? Part of the working out.
Sure. Anybody the fourth one working out?
No, I working it out, but I think I do something wrong somewhere along the line. So.
What are you?
Sir, is it that it go for the fifth one, is it going to be like mixed fraction?
All of these are mixed fractions. The 1024 over 27 is a mixed fraction. The 8192, the negative 8192 over 27 is a mixed fraction. All of those.
Sir, is it 262144 over 81?
Both. So I know you guys are getting it. Very nice. This is what I like. I like when I'm teaching and students are understanding and are trying. It's always a very good feeling. You don't all have to get it at the same time because we don't all learn at the same pace, but some effort. Some effort. I have enough time to do one more. How are we otherwise?
Good, sir.
All right, I have need for one more.
Sir, before we move on,
Mm-hmm.
the guess we never see the part.
You want me to work 4 and 5?
No, just the last part. Alright, the last part of 4, right?
Mm-hmm.
Where the denominator is 27. How you get that part again?
I get what?
The 27. The F.
This is talking about?
The fifth of, yeah. It's just the denominator part. It's just because I don't where the X value come from again.
Did you get this one, this up here, sir?
Yeah, yes, sir.
All right. So remember, I don't know how you guys are getting that without. Put it this way.
Oh, hold on. Sorry. No. Sorry, I don't get that part. That whole part here. Sir.
Okay, but did you get the 24,576?
Yes, I got that.
Great. So negative 24, 576 over 3 to the 4th. Honestly, when I get 3 to the 4th,
No.
This goes to 0, remember?
Oh. Okay. Yeah, man.
You see it?
Yeah.
So we have f to the, we have f to the, I'm sorry, we have 3 to the 4th. So that works out now to be negative 24, 576 over 81. And then I said 3 into 81 was 27 times. 3 into 24 goes 3 8 24. 3 into 5 goes 1 time remainder 2. 3 9s are 27 and 3 2 6. So that's why I end up with 8192 over 27.
Okay. All right. Hold on, yes, sir. Yes, sir. Thank you. Let me just get that off.
So we'll get the next question.
I don't know. Tinder, how you say, Maurice? You see all right?
Yeah, I'm all right now, sir.
Okay. All right. Let me just work through one quick one with you. Just one quick one. It is e to the 3x. E to the 3x. The differential of e to the x is e to the x. The differential of e to the x is e to the x. Hold on. The differential of e to the x is e to the x times the differential of the power. I think what needs to happen every day at the start of class, I need to just run a little differentiation question with you: product rule, quotient rule, chain rule, power rule. Because in order for you to do the applications of differentiation, you will need to know how you to differentiate your stuff. So just going to run through this quickly. We can start the class next week, God's willing, with this very question, seeing that we just have less than 10 minutes. It says obtain the first 4 terms in the Mclaren's series for the function e to the 3x. Hence, approximate the value for that. All right, e to the 3x. Remember, we're differentiating every time. And it says for the first 4 terms. So it means then that we're going to go, if this is the first term, we're going to go up to x to the third. F to the 0 is going to give us our first term. F to the 0 give us our first term. So f to the 0. Anywhere in the function f I see x, I put 0. So e to the 0 is going to be 1. But you know, sir, anything raised to the power 0 is 1. Then I'm going to differentiate this. The differential of e to the x is e to the x. So you know, when I differentiate e to the x, e to the 3x, see here I get back e to the 3x. But I have to differentiate 3x and I'm going to get 3. So I put the 3 right here. So very important. The differential of e to the x is e to the x. The differential of ln x is 1 over x. Those 2 differentials you must know. You must know them. The differential of e to the x is e to the x. Any function in the exponential that I differentiate, and we did this last week, we're going to get back the same differential, but we have to go work with the power and differentiate the power. All right? So this is going to be my first differential. The second differential now is going to be, when I differentiate here, I'm going to get 3 again, and 3 times this 3 gives me 9, and I write back e to the 3x. When I differentiate here again, I'm going to get 3, and 3 times 9 is 27, and I write back that. So this question is very easy, but it looks hard because it's an exponential function. Don't worry about that. Just work the something. Then now all of this, I'm going to substitute 0, but this here, anything raised to the power 0 is 1. So this is going to be 1 times 3 is 3. This is 1 again, times 9 is 9. 1 again times 27 is 27. So I'm just going to substitute it in the formula. 1 plus 3x plus this over 2 factorial x squared plus this over 3 factorial x cubed. See it right here. So I'm going to work it out. We're going to get that 1 here is a 1 here. A 3x and a 3x here. This is over 4 because 2 factorial is 4. Sorry, 2 factorial is 2. So we're going to do 9 over 2 x squared. 3 factorial is 6, right? So 27 over 6 is 9 over 2 x squared, and it done. We're not interested in these over here because it said the first 4 terms in the series. All right, and hence find the approximate value of this of 0.03. Anywhere in this function you see x, you put 0.03. So you're going to be 1 plus 3 times 0.03 plus 9 over 2 times 0.03 squared plus 9 over 2 times 0.03 cubed. That's all you do. See it here, so? Bam! That's your answer. And if you don't believe me, you can put in on a calculator e to the 3 times, no, e to the 0.03, and this is supposed to come out to be the answer. So you actually just evaluated e to the 0.03 without using a calculator technically. You use Mclaren series to get it. So e, and see if you can identify how to find e on the calculator. It's very important.
Sir, may I get 1.030?
That's what I said a while ago, because that's what I get. So I'm just checking my calculations again. That's what I got to son. So I'm just checking my calculation to see 0.2 squared plus 9 over 2 times 0.03 cube 0.914157. Yeah, that's what I'm getting to. Did I round off anything there? So nope. All right, I will come back to this one. I'll come back and look at it by the values, even though it's um like 6/10 about 100, but it should be a little closer. All right, by next week I'll tell you why this is happening. I'm going to eat on a Sunday dinner. I mean Saturday dinner. Jeez, I'm Sunday. Going to eat on a Saturday dinner.
Right, sir.
As soon as the recording becomes available, I'm going to drop it off in the group, in the channel, so you can have access to it. Please, students, you have Educasoft, start working. Start working. All right? Bless up.
Yes, sir. Next week.
All right, sir.
Come on.